Good morning, everybody. We're just going to give it a few more seconds, give people a chance to join. Obviously, we're on the hour at the moment, so we'll look to start in just a few moments. So good morning, everybody, and welcome to the third and final in this series of Subsidence Forum webinars. I'm Lauren Fairley, I'm the Secretary of the Forum, and just very quickly going to take you over some housekeeping bits for this morning. We have a chat facility. Obviously, most people are probably quite aware of this now, given how much Zoom is being used. A chat facility appears at the bottom of your screen. Please do use that to ask any questions to the panelists. We will monitor that throughout. On the chat facility, there is a drop down that you can either address your questions to the panelists or panelists and attendees. All questions that are asked at the questions and answers session will be anonymous as well, so obviously we won't read out your names. There is also the Q&A section as well. If you want to pop your questions in there, please feel free to do that. We will be monitoring both of them. Also, if you have any technical issues throughout, please also put that on the chat. Again, Chloe and myself will monitor that for you. Just to let you know, today will be recorded and it will be available on the Subsidence Forum website to view after this. And also, if you do have any issues with internet, please just bear with us. You know, all internet speeds are different. So I'd advise if you can shut down any other programs you do have open, it may just make that a bit quicker. Obviously, these are pre-recorded videos, so just bear with us on that. So all that's left to say is to pass you to Ron Mace and enjoy the webinar.
Thank you, Lauren. Good morning, everyone. And as Lauren says, welcome to the final instalment of the Subs Forum 2020 training event. My name is Ron Mace and I'm the current chair of the Subs Forum. I'm joined today by Patrick Isaacs, who's the head of Training and Education Group, Sarah Dodd, the vice chair, Angela Shah Structures, and John of Helifix. Patrick will shortly run through the revised format for today's event and provide a little bit of a feedback on last week's. Before I hand over to Patrick, and as per the last 2 weeks, I thought I'd just give you a little reminder of some of the objectives that the Forum is trying to push forward. These being, improve public awareness of substance issues, promote the substance industry, improve lines of communication between all parties involved in subsidence, improve quality and standards throughout the industry, and finally, establish a centre of shared knowledge and an exchange of non-competitive information. Today, at the end of the Q&A session, I'll come back and run through sort of some future events and activities that are taking place. Thank you very much, and I now hand you over to Patrick.
Thanks, Ron. Good morning, everybody. Hope you're well. It's another excellent turnout today. Another 200 people registered for the event, which is great. Hope you're enjoying the sessions. For those of you who have joined before, just please bear with me for a few seconds. I'd like to quickly explain what we're trying to do. As Ron mentioned, my name is Patrick Isaacs. I head up the Training and Education Special Interest Group within the Forum. And my main task is to arrange the annual training day, which for obvious reasons this year is all being done online. However, we are trying to mirror what we've achieved previously, where we've held demonstration days, where our members have demonstrated their skills in a live environment, replicating what they do when working on actual cases on a day-to-day basis. So as you can see there, we've had demonstrations of piling techniques, arboricultural surveys and tree identification, drainage investigations and repairs, and so on. Now, these days have proved a great success, and we were keen to do something similar this year, and hopefully that's what we've achieved with these video demonstrations and webinars. This is the final one, the last of 3. We've already had a mock-up of a tree root nuisance case that was presented by Sarah Dodd from DAC Beechcroft. We've also seen some complex repair examples from specialist contractor Optera. And we've also heard from GeoBear explaining about resin injection techniques in clay soils. All 3 of those videos have been extremely well received. And if you did miss any, they've all been recorded and can now be viewed via the Subsidence Forum website. So I'd urge you to take a look. We've got a strong lineup for our final webinar today. Another 2 demonstrators, starting with Shire Structures, who will go through some typical site investigations, showing us what they get up to on site and the various tests that are undertaken. That will be followed immediately by the masonry reinforcement webinar from Helifix. They'll be showing us some of their typical products and how they're used to remedy subsidence damaged brickwork. We'll then have a joint Q&A session covering both demonstrations. That's a change from last week where we had separate slots, one after each video, but we ended up a little bit short of time. So this week we're hoping that the one joint session at the end will save us a few minutes. I've also been told to keep this introduction short as well, so apologies if I'm rambling on again. So if you do have any queries or questions, please submit them as we go along using the chat function as Lauren explained. Sarah Dodd will be keeping an eye on the chat box and will collate all the questions for both demonstrators and submit these to the panel at the end of the second video. We should have a good 15 minutes or more for questions, so please keep them coming in. We'll be finishing at 10 AM and Ron will say a few words at the end to close the event for this year. Apparently that's all I've got time for. So I'll now pass over to Angela Griffin from Shire for our first demonstration. Angela.
Hi everyone, thank you Patrick. I'm Angela Griffin, I'm from Shire. Shire are structural engineers, most of you know us. For those of you that don't, we've been going for over 30 years, offering a wide variety of subsidence repair methods. The Subsidence Forum have asked us to cover geotechnical investigations specifically today. As Patrick mentioned, we won't be doing the Q&A straight after this. We'll be coming back to you after the Helifix presentation, but we will be holding a few polling questions directly after our presentation. That just leaves me to hand over to the video version of Ron Mace and my colleague Rob Ray. Many thanks.
Hello, my name is Ron Mace and I'm one of the directors of the Shire Group of Companies. I mentioned earlier that one of the objectives of the Subs Forum is to create a centre of shared knowledge. Over the last 2 years, the training events have been focused on the younger members of the Subs Forum and those people that generally don't get involved in the technical aspects on the day-to-day running of a subsidence claim. Generally, site investigation works are carried out to properties that have a potential subsidence claim. The purpose of the investigation works is to provide information so that the loss adjusters and all the structural engineers can determine how the property is currently supported and what the ground strata in the vicinity of the property is. The minimal level of site works will generally comprise a trial hole adjacent to the property and a borehole. The borehole can either be an extension of the trial hole or in a separate location. It is hoped that after this video, if you are challenged by a policyholder to explain what is involved in site investigation works, then you will have gained an insight into what they can expect. Site investigation works form only a part of the information required to determine the possible cause of a subsidence claim. Additional information in the form of crack monitoring, distortion surveys, drainage investigation and ARB reports also provide key information. For this video, I am joined by my colleagues Rob Ray and Dan Edwards. Rob is one of our geotechnical engineers and will run through the geotechnical process of a site investigation. Dan is one of our geotechnical technicians and will be operating all the equipment seen.
Thanks, Ron. Hi, my name's Rob, and today I'm going to take you through the practical demonstrations of a site investigation. Before a site investigation is carried out, we always check stats drawings. These provide useful information on buried surfaces, but these plans can't be solely relied on, and we'll also always carry out a CAT scan. In addition, we'll lift manholes and check for any drainage runs that may be in the area that we're about to investigate. When investigating subsidence, we have three methods of drilling boreholes. The first is the lightweight handheld equipment, consisting of a hand auger together with a shear vane or Macintosh probe. The second set of equipment is slightly heavier and consists of a percussive window sampler and a Pagani probe. The third method is a much larger tracked rig that can be used to take soil samples and also test the strength of the ground. The hand auger is lightweight equipment that can easily be transported and causes minimal disruption. Hand augers can be used to obtain samples of soil to depths of 4 to 5 metres. The disadvantage of this type of equipment is that it's not very powerful and sometimes it may not be possible to get to the required depth. This equipment would often be used to sample soils where we expect to find shallow clay shrinkage or shallow fill material. The strength of the soil can be checked using either a shear vane for cohesive soils or a Macintosh probe for granular soils. The percussive window sampler is still hand portable but far more powerful than the hand auger method. This enables borehole depths of up to 5 to 6 metres. We would generally use the window sampler with the Pagani probe where there is insufficient room for the tracked rig. This process gets its name from the cut window sections in the sample tubes. This enables the core sample to be easily extracted for soil logging. The strength of the soil can be tested using the shear vane, as with the hand auger holes, or to a depth of 12 metres using a Pagani probe. As well as strength testing in both granular and cohesive soils, the Pagani probe is also the preferred method of testing before and after resin injection. The rods are driven into the ground using a 30 kilogram drop weight. Greater depth is achieved by adding 1 metre extension rods and repeating the process until sufficiently dense soils are encountered. Once the test is complete, the rods are extracted using a portable hydraulic jack. The tract rig is the most powerful equipment generally used on subsidence investigations. The rig can sample soils down to a depth of around 9 metres and also test the strength of soil to a depth of around 20 metres. Here's one of our other operatives, Jeff, using the tract rig on a recent investigation. We have used the rig on sites where we are investigating deep-seated clay shrinkage or probing to investigate the extent of voids around a swallow hole. With this method, sample tubes are driven into the ground by a 63.5 kilogram chain-driven drop weight. The weight repeatedly strikes the anvil, which drives the tube into the ground. 1 metre extension rods are added as required to achieve greater depths. The tubes are extracted by the hydraulic jack. The sampling tube consists of an outer steel tube, a steel cutting shoe and an inner plastic liner. The liner is emptied and the sample is laid out carefully to create a soil profile for logging. The rig can carry out continuous dynamic probing in a similar way to the Macintosh and Pagani probes as we saw earlier. The test being carried out here is an SPT test. This test is typically carried out at 1 metre intervals. The SPT test is the strength test most commonly used in pile design. Okay, so here we've got the extracted soils from the first borehole. As you can see, they're laid out on a sheet in nice metre increments. The first metre here, you can see we've got a disturbed soil, so we've got a made ground. It's got little fragments of brick in it, so that's clearly not natural material. As we move down here, we're straight into a natural medium brown sand, and that then pretty much continues all the way through the borehole. Towards the end at 2.8 metres, the sand's sort of getting a bit cemented, and is turning into sandstone, which is what the geological maps did show for the area. If this was a driller's log, it would be just a basic description of what comes out, sort of made ground, brown sand, sandstone. An engineering description would go into more detail with the strength of the soils, because our SPT testing indicates it's a medium dense sand, and the sandstone at the bottom of the borehole is very dense. Okay, we've just completed borehole number 2. Slightly different ground conditions here. We've got a greater depth of made ground, a metre of made ground with some lumps of concrete, a little bit more made ground here, and then it goes back into the sand. But on this hole we have encountered some silty clay at about 1.8 metres, and that sort of continues all the way down then to 3 metres, where at the bottom it's becoming a weathered mudstone. Because of the clay, alongside the SPT testing, we also did some hand shear veins. So we've got the strength testing appropriate to the soil type. And also because it's clay, we are taking samples in these pots here. These will be tested for moisture content and plasticity, and they'll be sent to the laboratory, and it's normally a couple of weeks turnaround of getting those results. All this is just extra information for the design team when looking at a proposed foundation solution and any influence that the trees might have. Trial pits can be carried out so that details of the existing foundations can be obtained. The important information required is the depth from ground level to the top of the foundation, its projection, the type of foundation, whether this be brickwork spread or concrete, and the depths of the underside and underlying soil strata. Following completion of the site investigation works as demonstrated today, some of the soil samples obtained are sent to laboratories. At the laboratories, they will confirm our soil description and carry out various tests on the samples. I do hope, having watched this video, that you've gained a little bit of extra knowledge on the processes that take place. Thank you very much for watching.
Hi again, everyone. So thank you for watching. As I mentioned, we'll cover off some of the questions asked in the chat function at the end. This section now really is to go through a couple of polls that we've organised as per some of the last ones. So the first question, not necessarily going to answer them right now, we'll come to that at the end. Should a geotechnical investigation be carried out on every subsidence claim? Your options are yes, no, and don't know. We can see the results there. So 52% of people believe yes. There are 2% of people that don't know. Time for our next question. Is a desktop study reliable enough to inform decisions and design without any geotechnical investigations? Again, the options are yes, no, and don't know. That's interesting, very strong result there, 88% saying no, and still 2% of people saying don't know. And we have one final question. Do you see a different site investigation being carried out if a subsidence claim is caused by consolidation rather than clay shrinkage? Again, the answer is yes, no, and don't know. So should a different SI be carried out if the subsidence claim is suspected of being caused by consolidation rather than clay shrinkage? Okay, pretty balanced result there. So yes from 50% of people, no from 41%, and then a don't know from 9% of people. So we'll come back to answer and address some of these at the end. We'll hand over now back over to the Helifix presentation, I believe.
So thanks, Angela. Thanks, Angela. Hi, everybody. I'm just going to take this opportunity to hand over to John from Helifix for the next presentation.
Okay, thank you, Sarah. I hope Chloe is ready with the videos, but I've just got a short introduction to each of the videos coming. Helifix has been providing masonry defect superstructure solutions since the 1980s. The basis of the business was the invention of its helical profile with a central strengthening core, which has since been imitated by competitors. The systems have been both developed and proven to be hugely reliable, whilst minimizing the visual and physical impact on the structure. The major usage of helibars in the UK market is in the installation of completely hidden bed joint reinforcement for crack repairs and for designed load-bearing masonry beam creation. Hopefully we've got a video to go. Thank you. Step 1. Rake out or cut slots into the horizontal mortar beds extending 500mm either side of the crack to the specified depth. Step 2. Clean out the slot and then flush thoroughly with water. Step 3. Using the provided mixing paddle and a power drill, thoroughly mix the helibond grout. Step 4. Using the crack stitch pointing gun, inject a bead of helibond to the back of the slot. Step 5.
Using the helibar insertion tool, push the helibars to the back of the slot, ensuring good coverage. Step 6. Inject a second bead of helibond grout and then use the helibar insertion tool to ensure complete coverage of the helibars. Step 7. Repoint the mortar bed and make good.
Since the 1990s, Helifix has provided a remedial wall tie and general masonry pin, offering unrivaled speed of installation and a minuscule entry hole to disguise the intervention. This is the dry fix tie.
I'm Hayley Palmer. I'm the Area Technical Manager for the South East. We're going to be looking at the dry fix patented mechanical remedial wool tie. The dry fix tie is a very fast and economical remedial wool tie. Step 1. Test the inner and outer masonry to evaluate the size of pilot hole that's required. Then drill the pilot hole through the outer leaf and into the required depth in the inner leaf. Step 2. Fit the dry fix power driver attachment into a rotary hammer drill. Step 3. Load the dry fix tie into the power driver attachment and drive the tool until it is recessed below the skin of the outer leaf. The dry fix tie is a great product. It's very fast to install, it's reliable, it's versatile and it's very economical too.
In longer pinning applications and in certain substrates, the use of grouts is required, and the Helifix SEM tie offers an extremely versatile, proven solution to pinning masonry panels together and connecting perpendicular walls.
We're going to demonstrate the SEM tie. The SEM tie is a grouted anchor. It's used in many different applications. It's a very versatile product, and the way that it's installed ensures that there's minimal voiding during the installation. Step 1. Drill the correct diameter pilot hole to the specified depth and then flush thoroughly out with water. Step 2. Mix the helibond to the required consistency and do not add any water during this process. Step 3. Connect the pinning nozzle to the end of the heavy-duty grout gun, then inject grout to the end of the pinning nozzle and then twist the SEM tie up inside the pinning nozzle, ensuring it's fully encased in grout. Step 4. Place the pinning nozzle at the back of the clearance hole and inject the helibond grout, carrying the SEM tie with it. Step 5. Back pressure pushes the nozzle out of the hole, ensuring a fully grouted tie. Step 6. Make good the clearance hole. The SEM tie is an excellent tie. It can be used in many different applications, including overhead. The thixotropic nature of the helibond grout ensures that the grout won't slip back out of the hole and will hold the tie in place during curing.
The HD bow tie is a superb product introduced to the market 10 years ago, and it has proven to be the most effective proprietary lateral restraint tie for masonry to timber floor applications. Again, the speed of installation is extremely fast and only requires a very small hole. It works far more reliably than retrofitted straps.
My name is James Plaskett. I'm the Technical Area Manager for Helifix. I'm going to demonstrate how to use the HD bow tie. It's used to restrain bowing or leaning walls by tying the wall back into the floor structure. They're fast, easy to use and recommended when you're trying to restrain the wall into the parallel joists. Step 1. Mark the position of the bow tie on the external wall and drill a clearance hole, typically 16 mm diameter, through the brickwork. Step 2. Insert the HD bow tie into the support tool on an SDS hammer action drill. Drive the HD bow tie through 2 or 3 joists as per the specification. Step 3. Blow the dust and debris out of the hole. Step 4. Insert the sleeve over the end of the HD bow tie. Insert Polyplus resin, filling the hole, allowing to gel. The HD bow tie is a fantastic product. In comparison to traditional repair methods, it's quick to install, distributes the load evenly and is hidden within the fabric of the building.
In the last 10 years, Helifix has broadened its range to include heavier duty products where it is necessary. This includes the SockFix socked grouted anchor, which enables increased anchor lengths, more strength in bending applications, and the control of grout flow in hollow substrates. Helifix was founded in 1984. Over the last 36 years, they've been at the forefront of innovation in the design and manufacture of construction ties, fixings, and masonry repair systems. The success has led to them becoming the generic name for many systems of masonry ties and fixings based around their helical profile. Helifix has gained an enviable reputation for product quality, engineering excellence, a high level of customer service, and professional support. Helifix manufactures high-performance stainless steel ties, fixings and masonry repair systems for all common construction materials, which have proven to provide reliable, cost-effective remedial solutions. Helifix consistently tested its products with leading independent bodies around the world to check the efficiency of the systems and also to make sure they are effective in local substrates. This has also been necessary in many cases to ensure that the techniques adhere to the local building codes. There is a huge database of testing that's been carried out over the last 36 years, including a small amount shown on this slide here. Five years ago, Helifix has identified a need to add to its portfolio of masonry repair systems. The systems had principally been based around its helical profile that had been introduced in the 1980s. The SockFix is different. SockFix is a cementitious, grouted, socked anchor, and it allows for longer drilling distances, high load capacity, especially in bending, and also, as will be demonstrated in the video, where control of the flow of the grout is essential to be effective in voided substrates such as CMUs, the SockFix offers an ideal solution. All Helifix product sheets, including the SockFix one shown on screen now, can be downloaded from the helifix.com website. These detail the common applications and the properties of the products. The installation method is also included, and that will be shown on the video to follow. Resin anchors have been the preferred method of anchoring to stabilise masonry veneers since the 1970s. They benefit from ease of installation and rapid strength development. In the last 20 years, the US has experienced multiple failures of these systems. Typically, at least part of the problems with the systems is related to the difficulty of cleaning out dust and debris from the pre-drilled holes effectively. Helifix is introducing change to the anchoring business for facade stabilisation. Socked cement anchors have been used in many other applications for 5 decades. Their use has a proven track record in both masonry and concrete. The essential need for thorough cleaning out of the pre-drilled hole is considerably reduced. Cementitious SockFix have been proven through testing to provide far superior performance to typically used resin-based anchors. Hollow substrates can be exceptionally well fixed into using this technique. Historically, a significant drawback of socked anchor systems was the need to use paint pressure pots with a compressor to inflate the anchors. This was a cumbersome system and involved time-consuming and messy setup and considerable clean down after use. For small anchors, small projects and difficult access sites, Helifix has looked into the marketplace and has tested and introduced both handheld air and battery operated grout tube guns. As the anchor sock expands to its full potential, the anchor locks either side of the wall of the CMU, as you can see in these examples. What you can see here is the inflation of a sock fix anchor using a battery powered cartridge gun, and you can just see the expressed liquid component of the grout making its way through the semi-permeable sock of the sock fix anchor before the filling tube is turned over and then tied prior to curing with a cable tie. Once this is done, you can see the speed of the installation, and the next anchor can be moved on and exactly the same process carried out. Finally, the video demonstrates the use of a pneumatic gun connected to a compressed air supply, inflating the anchors in exactly the same way as we saw with the battery gun. In this close-up shot, you will see how effectively the anchor is inflated, creating an integral bond as the sock expands larger than the diameter of the pre-drilled hole either side of the wall of the CMU. This is creating an integral bond which, once the anchor is cured, cannot be removed without considerable damage to the CMU wall at high loads. In summary, over the last 36 years, Helifix has worked hard to develop and test non-disruptive, innovative approaches to masonry defects repair. The systems accommodate normal structural movement and produce excellent holding power in all commonly used building materials. They've managed to achieve a massive reduction in terms of physical and aesthetic damage to the structures they're working on, and they provide excellent load transfer capabilities. The techniques are far quicker and simpler to install in comparison with traditional repairs, and generally are far more cost effective. Quality control of site installations is carried out in every case, and on-site testing of installed anchors can easily be carried out using mobile test rigs. Okay, I think Chloe's going to start the next presentation now. In addition, Helifix has introduced a designed calculation-based solution to the stabilisation of 1 to 2 storey masonry buildings using end-bearing screw piles. The system includes a complete upfront computer software-based design calculated using site soil investigation results. Then, on installation, 2 checks are carried out. Firstly, the continuously measured torque required to install the pile has a well-established correlation to the achieved bearing capacity. And secondly, the underpinning bracket is jacked off the pile to mobilize the load of the building onto the piles. The installation equipment has been refined to be transportable through domestic doorways. This product has been extensively used in the US for 40 years and in the UK for 10 years, both in underpinning applications, but also in reliable designed new build applications, such as with prefabricated units.
Thank you, John, and thank you, Angela. So thanks to Halifax and to Shire for your presentations this morning. If I can get you all to pop onto the chat so I can raise a few of the questions that have been coming into the chat box. I know a few of them have been answered in the chat box in real time, but I think it would be good to open up the floor to ask a few of them to you guys so we can get some conversation going. The first one, a bit of a generic question and potentially a tricky question, so I'll throw this one open to the floor. So at what stage can you decide, do you decide on groundworks needing to go ahead rather than just superstructure repairs? Is that a simple decision to make? Angela, John, do you want to come in on that?
From my perspective, it's all down to making sure that you are understanding the needs of the client and you understand the project that you're working on. And the main answer to the question is whether the substance is ongoing. Because if the substance is historic, happened 35 years ago, and you've got cracking and the door heads are all over the place, why would you be going to the environmental impact and the mess and the cost of underpinning works of any sort? But if if there's a strong possibility of the ongoing issues, then yes, you're likely to want to stabilise it, unless the client or the budgetary constraints or there's no time for monitoring mean to say that the client wants to accept that risk and then go ahead with a superstructure repair only and see what happens on a suck it and see basis afterwards. So it's very important to understand the structure, how it's put together, what that's caused the defects, whether those defects are ongoing. That's the crucial question. And then after that, discuss that with the client and the options that they've got open to them to address that.
Patrick, do you want to add anything to that?
Yes, I will, Sarah. Thanks, John. I agree with everything you've said. It's not an easy question to answer, really. You've got to consider the cause of the damage, the severity of the damage, the history of the property and the subsidence problems it's experienced, whether there's any mitigation available, drainage repairs or tree works, the likely success of that mitigation. So you have to put all that in the mix, and then you've also got to consider the cost of the various options and the risk associated with each of those options, bearing in mind that those nice people at the FOS require us to deliver a lasting repair these days. So whatever solution we do come up with, we've got to be confident it's the right solution for those circumstances, and it's going to stand the test of time. So there's a whole range of information that you've got to consider before you can give an answer to that question, Sarah.
Angela, can I go back to the poll questions that you raised, just to ask what your observations were on the answers there? So the first question then was whether the first question was, should a geotechnical investigation be carried out in every claim? And oh my goodness, it was all but a 50-50 response. I think 52% yes, 46% no. So what do you think? What do you think in answer to that? And what were you expecting to see?
I was expecting to see a split, interestingly. So go on, Ron, you've got a point to make.
No, I was going to say, I always think, depending on who's viewing the video and depending on the person's involvement in a substance claim, you're going to get different response. As a structural engineer, I'm always going to say you should do a site investigation, because that's part of the information. And I think we mentioned in our video that it's just one piece of the jigsaw puzzle needed to understand subsidence of a property. So I'm always bound to say you should always do them, but not everybody will think that way.
Yeah.
I'd be interested to hear from the people that think the answer's no, why they think no. That would be interesting to explore a little further.
Okay, well, on the poll, 50% of the delegates said no, and I would challenge Ron that if he turns up to a property in a North London borough, which he knows is underlain by 20 metres of London clay, what's the value in spending £750, £1,000 doing a trial pit and a borehole when you know beforehand what you're going to find?
Partly to give you cost certainty, Patrick, because obviously one of the criticisms can always be is that we can do it, do a stabilisation scheme, but when you turn up site and you sort of say, well, it's in London, so you're going to need a particular type of pile and you can estimate the depth of that pile, you actually then need to know the soil profile to work out, should that pile be 8 metres deep, should it be 12 metres deep, the level of destination. You know what I mean? So that
substructure scheme, then I'd agree there is a need for some soils information. But if you're trying to identify the cause of damage, I would argue that it is not always necessary to do a trial pit excavation to confirm that.
Yeah, I agree to a certain extent that if you turn up to a property that's called Oak Cottage, and as you get to the drive, you see the biggest oak tree in the world, and it's a clay soil, you've got a rough idea of what the problem is, haven't you?
Yeah. I know as a solicitor, we would always be looking for soil investigations in every case, and an investigation bespoke to the particular property that was the subject of the claim. Can I just ask one of the other ones, Angela? So, desktop study reliable enough to inform design? We can't vote as panelists, can we? So I was trying to click no no, and I just well, 88% of people were obviously in agreement with me and wanted to know. So have you got an observation to make there?
Yeah, absolutely. I mean, I think Rob covered the point, actually. I'd like Rob to step in and answer this one. So Rob covered the point in that example. The desktop survey predicted that we would find sandy soils, which we did in the main, but there was a surprising find of an element of clay soil in there. And obviously a desktop study will never show you the exact profile. It will never show you the depth of varying soil types. So if Rob can step in and make a comment.
Yeah, it's a desk study is always useful because you can tell us what we expect to find. You might look at site history, that kind of thing, but you never really know until you do boreholes what's there. You could have some infilled ground, there might be an infilled pond. You just don't know for certain. And also a desk study will tell you nothing about the strength of the soil. You don't know that until you drilled in the ground and you've done some strength testing. So all that information is definitely required from an intrusive investigation.
Can I ask a question of my own, Ron? When we showed these sort of the sausages of soil that had been taken out and being put into those plastic pots, and I think you said in the video, Rob, that there may be a couple of weeks between, I think it was you, between those being put in the pots and then taken off to the lab. So what effect does that sort of hanging around element of it have on the moisture content of the soils? Does it have much of an effect?
Not really, because when you take these samples, there's a certain process. You'll wrap them in cling film, you'll put them in airtight containers, get to the lab as quick as possible. And when they're at the lab, they're under laboratory conditions then, so they're monitored and the moisture content's tested. So it's getting to the lab as quick as possible, basically.
Okay, great, thanks. Let me have a look at some of I know, John, you're answering some of the questions that were being raised about Helifix in the chat box, which was great. So I think somebody asked about general builders being able to install Helifix bars up to 1 metre and whether anything longer than 1 metre could only be installed by a Helifix approved installer. Do you want to make some comments on that?
Yeah, I've put the answer in the chat box there, and someone else has come across the top as well. But the answer basically is yes. We sell heli bars up to 2 metres to anybody. We limit the length at 2 metres to approved installers on the basis that we believe that for structural works, particularly load-bearing applications, we would like to see that done by trained approved installers who both have been shown directly by us how to install the bars, and on top of that should have an understanding of the consequences of what they're doing and doing it wrongly. So from a Helifix perspective, you won't get longer than 2 metres from a general contractor, but as someone else has put on the chat, certainly some of our competitors will sell you a 10-metre coil without a problem if you want to buy it.
Mm. And what about things like your involvement with building regulations? During the animation there, somebody raised whether building regulations approval would be required for the installation of those piles.
Yeah, very commonly it is, and on many occasions we have provided calculation-based design for building regs approval within our projects.
And there was also a point that cropped up as well about heave protection. Is there any heave protection as part of those as well?
Yeah, and that's the point I made on there. The diameter of the piles is 2 7/8 of an inch, which is about 72 millimeters, and they're end-bearing piles, not friction piles. And as a consequence, within the heave zone, the friction forces are very, very low. So generally, you wouldn't be worried about the pile itself. But of course, one of the benefits of the system is that you don't touch the existing foundations or excavate them, which means to say that they will be affected by heave afterwards if heave is a possibility. So Helifix will always advise the clients about heave, ask the questions about heave, look at the soil investigation results, see whether heave is a possibility. And if heave is a possibility, then the client will be advised that excavating under their foundations and putting clayboard in there would be required.
John, is your solution usually done in isolation or in conjunction with something else, such as a root barrier, or as it with mitigation, so tree removal? Is it a standalone solution?
Well, I mean, Helifix, if you think about it, it's been around for 30 years, and our basis is not piling, it's not screw piling, it's not it's not substructure work. So we will normally look to be removing trees, repairing drains, dealing with the cause of the problem, rather than getting interventions under the ground. But when one is required because you can't remove the trees, or there's another issue that's causing it, that's when we will propose our system. So generally, we'll be looking to take the cause of the issues away first, rather than putting things into the ground. But obviously, there are situations when you can't, and there will be situations when, between the discussion between the engineers and the client, the Helifix engineers and the client, that there will be a decision to both carry out the mitigating measures and use screw piles. But obviously, screw piles, stabilizers, whichever product's underpinning, it's a cliche, but it's horses for courses. There's always going to be a good number of options open to a client if they do need a substructure intervention. And we will propose our pile where we think it is appropriate, with or without additional measures to mitigate the cause of the problems.
Great, thank you.
Sarah, can I just ask a quick question there of John? There are probably quite a few interested parties in the crowd, and they'd be very interested to know roughly how much your screw piles cost. Are you able to give a sort of rough idea?
That's always a question. Yeah, how much? But obviously it's going to depend on a number of factors, and that depends what the site investigation results show, how deep the piles are going to need to be installed, what spacing they're going to be at. Typically the spacing is going to be 1.5 to 2 meter spacing, can come a little bit closer with a reduction factor on the load bearing capacity on occasion. And it really does depend a lot on, the site conditions and what you're finding and the length of the pile. But as a realistic guess, let's say maybe around the £1,200 a pile figure. We used to think it was 800, but I think that in reality, the last 5 years have shown us that's the rarity rather than the norm. And 1,200 is much more the norm. And if they're a bit longer, if site situation's a bit more difficult, it may well be £1,500.
Okay.
If I can just jump in there and just remind people about uncompetitive section, there are other companies, other products out there that are available.
Can I just raise one quick final question before we hand over to Ron for the closing, and actually maybe a question for Ron. And in a time when we're all very conscious about decontamination, cleaning up, washing our hands, etc., etc., someone's raised a question in the chat box about whether there's any cleaning done of those rigs, Ron, before they go from site to site to prevent, or is there any risk of cross-contamination from different soil samples?
There is a general cleaning of the equipment, yes. Obviously we don't use the same tubes all the time. The plastic tubes that Rob showed you on that particular one, they pulled the soil out. Generally they will split those tubes in half, so they're all thrown away anyway. So any sort of cross-contamination is really down to an absolute minimum. But yes, all of the different kit is cleaned each time.
Great, thanks Ron. Well, back over to you then for the...
Okay. All right, well, thanks, Sarah and everybody. I'd also obviously like to thank my twin brother who turned up for the Shire video. Thank God the man's had a shave in a week. Just to go through, in respect to the various questions that have been received either by email or submitted via the chat function, the intention is to get answers to all of these questions, put them together in some sort of a podcast that Sarah, Patrick and myself will record sometime over the next few weeks, and we'll make that available via the website. That's sort of trying to in keep with everything else that we'll be doing this year, sort of using technology as best we can. I think it's also worth saying that the decision to run the training event this year, rather than go for the easy option of cancelling and blaming the COVID pandemic, was made towards the end of May. Therefore, we've only had 4 months to pull all of this together, which has also been the first webinars that the sub-forum's done. The initial figures of what I've been looking each week at participants and looking at who's registered have suggested that over 700 people have registered for all 3 events, and a staggering 550 people have logged on and joined us for the last 3 Fridays. So to Patrick and Sarah, I can't thank you both enough. Absolutely fantastic. We've done it. Well done. To Lauren, Chloe and Emma of AGM House, thank you for your patience, your guidance over the last 4 months. And for us as a team, I think we probably ought to have some sort of a Zoom celebration meeting at some stage. We'll have to sort out how to do that. I'd also like to thank the various companies that have taken the time and effort to pull together their video presentations. Having been one of those people that had to stand in front of a video, listening to the words of, Ron, can you just do that again, please? I have shared your pain. And I think, if possible, a virtual round of applause for everybody would be appropriate. As this session closes, there will be a survey asking for ideas on future webinars and demonstrations. I ask that you please take the time to complete the survey, as the feedback will shape next year's event. Obviously, at this stage, with the current situation we're in, I'm not sure if this will be a webinar or a live event. Live events are obviously better because it gives us that opportunity to do a bit of networking, and it's good to actually see everybody. But we're going to have to wait and see how things pan out next year before that decision's made. Hopefully, some of you will also feel that your organisations can help us with future events. And if so, please could you contact either myself, Patrick or Sarah, as planning for next year's event is likely to commence round about Christmas time. Finally, and I think I'll probably bored everyone to death, is just to remind all members that the AGM is next Friday, the 23rd, and starts at 9:30 AM. That's it. Thank you for joining us. Take care, keep safe, and have a good weekend. Thank you very much.